Now it should work.
Yep.
Perfect. Yeah, today we will do it in basically two stages. First of all, I will talk a bit about what process mining is, how we can use it, where it basically comes from, and why it has a merit to exist, so to say. And in the second stage, I actually brought a little demo data set for us to explore a nice question. And then afterwards, but also in between, however you like, I'm flexible, we can have some Q&A. I also brought along my colleague Philip, who is a very experienced data analyst, and we will both be happy to tell you a bit about PAFNow and process mining today. So yeah, the first question obviously is an expectation. So whenever we encounter any kind of process or any kind of model in real life, we always have an expectation of how it should work. And today I brought you the process of a parking lot. So how we think a parking lot should work, right? It's quite simple. A car approaches, the gate opens, and that's it, right? But often in life, expectations don't quite meet the reality. And we think that process mining can be a very potent tool to basically try to explore how this reality came about and why our processes don't look quite as they should. So maybe we take a step back and talk about who we are. So PAFNow is a thought leader in process mining. And why thought leader? Well, we are heavily engaged in university research. We received big grants from the federal agency, but also other agencies. And we actually embarked on the journey not so shortly ago. We actually been there for 13 years. And it all started with the first prototype from Eindhoven University in 2008. And our founder realized quickly, he's actually in the middle standing, that process mining is a potent tool, and process analysis is the way to go in the future. And so 6 years ago, after being involved in a lot of projects where he used different kind of tools, we decided on developing our own tool, which is PAFNow. So before we were called PAF, and we're having the tool PAFNow. And with the PAFNow, we now had over 300 process mining projects for all kind of sizes of companies, Fortune 500 companies, a lot of big companies in Germany as well. And we've been basically recognized by a lot of vanguard organizations like Gartner, Forrester, maybe you know a few. And let's maybe talk about process mining. And the first step in process mining is we need a process. So the question remains, what is a process? Well, a process is basically a sequence of activities to achieve a specific goal. And so we always have a starting point, we have different events, we have things that happen, for example, in between the events, and we have an endpoint. And the interesting thing about how process analytics used to be is maybe that in the past, people were sitting in their small chambers and were thinking about the process, how should it look? And then they were basically giving the process to the people actually working with the topic. And then people were executing it. And maybe after half a year, those said people would go to the people executing the process and would ask, my dear colleague, how are you actually executing what I thought of? And if we even precede the concept of them telling you the complete truth, which we, for the sake of the argument, will do, the question still remains, well, are they actually able to tell you exactly what they did? Or maybe did they sometimes deviate because the process didn't quite work as they thought it would? And this is where actually process mining comes into the picture. Because in the past, we always had our ideal, and on the right side, you maybe see the reality will look a bit different. So you will have a lot of different ways of a task that was actually done. And what process mining basically does is, it's a discipline that combines data mining and process management. So in every process, we always leave timestamps, we always leave activity names, for example, the SAP process data, and we use those timestamps to automatically create those process trees, we call them. And with this data collection, we can go directly into the IT system to visualize our business processes and have an idea of what the process actually is, because only then we're actually able to perform some kind of optimization. Because if you don't even know what your actual process is, and if you implement any kind of optimization, you don't even know the beginning. So how can you know the next step? And that's why process mining is a really potent tool. And this is only the beginning of how we can use it. Because basically the use cases we've been encountered, the typical ones are procure to pay or order to cash or plan to deliver, but the possibilities are countless. So you could have a manufacturing client on the shop floor level, and whenever a process may be really slow, you can tell the people on the shop floor level directly, guys, look out, this process is really slow, maybe fasten it up so we are not losing any kind of sconto in the end or whatever. So this is why process mining is a really interesting field, and that's why it excites me to work in it. So in order to make it a bit more tangible, I brought you the example of baking pizza, because I feel like pizza baking is always an example which everyone likes, at least I do. I'm an avid pizza eater. And in the example at hand, we have a really digitalized pizza bakery. And it's digitalized because we are tracking all the different steps. And so what kind of steps do we have? Well, we have prepared dough, we have preheat oven, we have spread tomato sauce and put it on the dough, we have add cheese, and we have bake pizza. And this is our first process, and this is what we call a variant, because if you look a bit down, we have a second variant, which is the vegetable pizza. And the only difference really is that we add vegetables at a certain stage. And now you already know the concept of the process, and you know the concept of the variant, which is basically a different way of how a process was actually executed. And if we want to analyze the process mining with our tools we now learned, we need three things. We need to have an event log, and this event log needs to have, first of all, a case ID. So it's basically a unique identifier, not on a variant level, but on the very case level. So now I'm baking pizza 1, and in 5 minutes I'm baking pizza 2. So that's the case identifier. And the second thing we always need to have for the event log is the timestamp. When it comes to the granularity, there's always a difference. For example, in the case of pizza baking, it's always interesting to have the minutes and seconds, because pizza process usually doesn't take hours or days. But depending on the process you want to actually analyze, it can be on the different levels of granularity. It can be on the hour level, it can be on the day level. It always depends. But for the case of hand, we really want to have the minutes and the seconds, because we want to analyze how we bake the pizza. And the third thing we really need for process mining, this is essential, is the activity name. It's basically the steps I already talked about. It's prepare pizza dough, it's preheat the oven, spread tomato sauce, so on and so forth. So these three things, we could also start analyzing our process. But when process mining really gets interesting is when you have additional info. And those are the case attributes. So it could be, for example, the kind of pizza. So we learned two things: the margherita, the vegetable pizza, could be pizza salami. I don't know what everyone likes, maybe tuna, maybe Hawaii. I guess that's a controversial topic. I like Hawaii, but some people don't. We could have pizza size, we could have the price, we could have pizza store. So for example, one use case that comes to our head is when we do some kind of benchmarking. So if we compare processes in between different pizza stores, for example, this attribute would really help us to determine whether a pizza store is really behaving as he should or she should, or it should, or it's behaving a bit differently. And then you can also find out which pizza store has the most efficient process. So with those case attributes, you can actually learn a lot about process mining and about the process in general. So when we have these three things, we put them in our data model, and out comes the process. And this is what we will actually now do. Because if we remember our first slide, we are still at the parking lot. And we look out of the window, and this parking lot doesn't look good, because luckily for us, it snowed. And we actually see that someone just went around our beautiful gate. And now that we want to analyze it, we need to have an intelligent parking lot, a digital parking lot. And or I call it a conscious parking lot. So what we need to have is, first of all, smart gates. So we want to know, okay, whenever a car passed the first gate and the second gate, we can find out if someone basically attempted to go through our process. And the second thing we need in order to catch the people that actually went around, we need to have some kind of way to know when the gate closed or opened, because now we could know, okay, someone approaches the first gate, the gate didn't open, but he went through the second gate. That means someone went around our conscious parking lot. And now, having this kind of information, we will now go into the tool and we will start discovering what about our conscious parking lot. So let me switch the screens really quick. So now we are in Power BI, and I already loaded the data in. And maybe to catch you from where we left off, we still have.
Sorry, Mark.
Yeah, Mark. Yeah, we just see slides.
Exactly.
Okay, wait. So now you should see my screen.
Data types. We see data types. Categoric.
I would just start resharing.
I think it's your desktop background, different visualizations.
Yeah, that's no problem. So now,
yep.
Yes, very nice. So exactly. So now we talked about those three things we need. We need the case ID, the activity name, and the timestamp. And we have all of those three things in our data set. As you may see, we have the approach gate, close gate. We have insert card. We will talk about that later. So we have a really conscious parking lot, which gave us all the information we need in order to now start analyzing. And now we go into the setup, because we want to know maybe how our processes look. Let me quickly hide this thumbnail. Okay, exactly. So now we have our PAFNow vision, and we'll talk about all the different things you will see on the screen. But first of all, we need to put in activity name target, and then we will see the magic of process mining, which is we see the process, the first iteration of the process. So what do we actually see now? Well, first of all, in the middle, we see the automatically created process graph, and we see, if we contextualize it, we see how we would think our process goes about in our conscious parking lot. So let's say someone approaches the gate, presses the button, retrieves a card, the gate opens, someone passes the gate, and the gate closes. And what we now also see on this page is, on the bottom, we see a slider. And with the slider, we can go through all the different variants, and then we will see which kind of different ways someone went through our process of the parking lot. And maybe some kind of background. On the left side, it's always the most commonly used process. And on the right side, there's the almost least commonly used process. And maybe on the right side, just for first glance, but we'll talk about those later, we have a duration card. So based on all the different variants we have selected, and the duration is displayed. We have two gauge visuals, which display the amount of cases in the data set given and the amount of variants we have given. We have a variant filter, and when we have a tree map with different attributes. But let's maybe go back and first of all focus on the process graph. I will do it like this. So now we want to play through, okay, which kind of ways did someone actually go through our parking lot? And that's why I will drag the slider to the right. And we will see, okay, the second variant was actually that someone inserted a card. So apparently this must have been the people that retrieved the card, went in and then went out, inserted the card, the gate opened, and someone left again. Okay, nothing unusual yet, right? That's still the way the parking lot should work. What about the third variant? Okay, interesting. Now we actually see that there's a new variant which is completely different from the first one, which is someone inserts money. So apparently there's also a way to pay for the entrance. It's not just maybe a different kind of validation method. That could be a first insight. Okay, if you have to pay sometimes, maybe there are people that just don't want to pay, and that's why they go around. Could be interesting, but we will see later. The fourth variant is now a new kind of concept we see. Maybe you missed it, so I will do it again. A small circle appeared. And a small circle in our visual will basically tell us we have a self loop on this point. A self loop is basically a rework of a process If we take it to the big picture now, a rework is not really wanted because that always means like a process, for example, in your company has way more cost attached to it because maybe the person that executed the process didn't really know what to do, or the process was set up in a way that it was not exactly clear how to do it. So a self loop is not really wanted. But for the sake of the argument now, we could imagine someone approaches the gate and presses the button really a lot. And maybe we know it from when we stand on, I don't know, a traffic light, right? And you really want to cross the street, and so you press it multiple times. So maybe that's the case, but we will see. But that's just the fourth variant right now. So if we go further through it, okay, the fifth variant, someone is calling the reception and leaves the gate. So he doesn't even make it through the gate, he's just calling the reception, but now we know, okay, there's always someone to speak to the person. The sixth variant, okay, there's also a way that you can actually talk to the reception. So apparently in the first case, just no one picked up the phone. And you can also talk to the reception. In the seventh variant, we see, okay, someone approaches the gate and leaves the gate. Could have been that they maybe took the wrong way. We don't know yet. Can be different kind of reasons. In the eighth variant, we now actually have someone going successfully through the reception. So the gatekeeper actually left someone in. That's a good sign, right? So someone was able to convince the receptionist to let them in. And now we have the ninth variant. And now it gets interesting because now we actually have the case we were interested in, which is someone approaches the gate. So if you imagine the first point where we check if someone crosses over the line, someone passes the gate. So they went basically through the gating process and then they finished the process. So that means this kind of whoever did this process was the person or the group of persons that were not interested in going through our process. Maybe they didn't want to pay money. And we want to know a bit more about it. And maybe a first point of interest could be, okay, how severe is this actually? So how many people actually do this? So what we could do is we pull in the case ID and see how many people went through this kind of process. We might already have known, because I talked about it earlier, we have 10,000 cases. So we also see here the 10,000 cases. And now if we were to focus on this variant, we see it's 267 people that didn't like to go through our process. That's interesting. I mean, it's not so many, but it's also, I would say, some kind of some. So it's some people that really don't like to go through it. And what we now want to embark on the journey is we want to know who was it and why did they do it. And I want to maybe go back to my slides and I want to talk about maybe if you now see this picture and this could be a moment where we have some kind of interaction. If you now have those two information, you have the information people could pay money and people could also get in without paying money. But there are still people who just went around and didn't pay. There would be maybe a really simple solution, and maybe someone wants to speak up and give me a really simple solution now if we just have those information, how we could now solve our process. Yeah, I see a lot of people want to interact. I can give you a really interesting way of solving the problem, which is from our friends from North America, from our orange friends from North America. Ah, we see a chat message.
Yeah. Chat maybe.
We use a fence, yes, of course, but we can also use a wall, right? We could build a wall and make, I don't know who pay for it. So we could use a really popular politic measure to just build a wall around it, right? That would solve our problem, right? Then everyone would go through it. And now it gets interesting because, yeah, I think it could solve our problem, but was going around actually the problem, or could it be actually a symptom? And in order to find that out, that's why we have process mining, because what we will do now, and we will go back to the raw data. I mean, the data is already loaded in, but in order to maybe show you, we put in some case attributes. So we put in, for example, the car color. Oops. We put in the car color, the car maker, the direction, the driver type, and if they're bypassed or not. So based on our additional attributes, we now are actually able to analyze it deeper, because so far we know, we get some kind of hint what happened, but maybe if we know who did it, when they did it, under which circumstances they did it, then we can actually start finding out why they did it, and then we can actually make a proper facts or data-driven argument on how we could change our process. So now we will leave the setup page where we spent some time, and we will actually go to the difference analysis, because now we want to know, well, when did the process actually change? And for that, we can basically start selecting all the months. And what you will see now in the picture is basically you have all the months based on different colors. But if it's in that black, it means that all the processes selected so far went basically all the same. So everyone did the same. So now if we are going through all the months and we see an additional color popping up, that's when we know something changed in the process. And we maybe also see that something will happen there, but let's go through it one by one and see if something changed. But so far we see nothing changed. And now let's see what happens if we select November 2019. Something yellow appeared. Oh no! And it's actually the case we've been talking about. It's the variant number 9, right? It's the most uncommon one. And in the November 2019, there have been 21 cases. But if I were to select, I mean, for the sake of the argument, just select all the other months as well. Then we see all the 267 again. So we know now that in November 2019, something must have changed, right? But now if we have contextual knowledge, we have 2 text messages. Fence doesn't help if the people going around were the ones who couldn't reach the reception. Yeah, could be a reason. Good one, could be a reason. We will see, but I like it. We could contextualize our knowledge, because maybe I'm the owner or I'm the IT guy of our conscious parking lot. We would know if something changed in the people that maybe access the premises. Maybe we had an error in our parking lot automate. I don't know. I could already get a hint. But since we don't know that much about it, we don't know the contextual information, we have to go a bit deeper into the knowledge. And that's why we now will go to the root cause analyzer. And I will talk a bit about what we see. So on the top right, we see the lead time again. It's the average throughput time, basically through all the processes selected. We see the cases and the variance in the gauge visual, that's already known. We see a new field, which is count bypassed by bypass. So we basically put 1 into everyone who went across the gate, but never interacted with anything else. And we put a 0 if they didn't do it. That will help us a bit for the analysis. But the main part about our analysis now, our root cause analyzer. And this is actually a PAFNow custom visual as well as the process explorer. And with a root cause analyzer, we can explain basically a set of data based on different attributes. I put in now driver type, car color, car maker, and direction. And if we now will make a selection based on those attributes, it will try to explain the process. So maybe let's select bypass. So now select everyone who bypassed, right? It's the 267 people again, or the cases again. And they actually have a really short lead time. Interesting, right? 29 seconds, that's fast. But now focus on the root cause analyzer. And what the root cause analyzer tells us, okay, we have a driver type manager, which drives a white Mercedes. That's already interesting. That's breaching, I guess, some kind of GDPR, because I guess how many white Mercedes managers are there, right? But we also see driver type security. Okay, so apparently managers have a tendency to not wanting to go through our process. Okay, we can take that for a short learning. We don't really know yet what to do with it, but I guess we have it in the back of our mind, right? And what we could also do now is we go based on all the cases that went through a different node, a different activity node, and that's why I've put them here on the bottom right. And maybe if we go through approach gate, because right, everyone did that, and yeah, okay, the root cause analyzer cells, yeah, there were a lot of people arriving and also a lot of people leaving, so they have that in common. Doesn't really help us. It's not the above and beyond the root cause analyzer, but it gives us a feeling of what could happen in the background. Okay, for everyone passing the gate, that's everyone, right? We remember that's everyone who actually went through the process, but we don't really know yet if they really did our process. Those would be the people that close and open the gate. And here we see we have employees. So apparently we are actually owning the parking lot on our premises. We have maybe a factory or something. So maybe our main business is not having the parking lot as a source of revenue, but rather as a source or means of our workers getting to work in time. What else do we see here? Okay, we see some managers. So apparently managers are also able to go through our process without skipping the row. So that's interesting. So not all managers in our company are bad. We have the driver type event. So interesting new learning now for us. There are actually events on our premises. Okay, interesting. And now we also have a small bubble, driver type visitor. Okay, fair enough. Maybe let's go a bit to the rarer used nodes. Maybe we see talk to reception, who actually were able to talk to the guys at the reception, or the girls, obviously. We have driver type visitor. So, okay, yeah, makes sense. If you're a visitor, you don't really know what to do, right? So you talk to the receptionist and find out. We have driver type post. Yeah, makes also sense. Driver type maintenance and driver type unknown. Sure. Nothing really to get from that, but we will see at a different page what we can do with it. And now we have insert money. That was a hypothesis, right? The hypothesis was that maybe people from my company have to pay, but since we see that no one of our company ever paid in the first place, there's a less likelihood now, right? Because now we see 100% of everyone who ever inserted money, so 100% of everyone who ever paid to access our premises was an event type. So maybe let's assume on the weekend where the parking lot is empty, we extra source of revenue, or maybe the city asked us that we want to have an event, and then we just say, yeah, sure, use our parking lot. They have to pay some money for the usage, and that's all fine and dandy. But now, if we connect the dots, if we were, and I jump back to this slide, if we were to put around the fence, we wouldn't have solved the problem, right? Because there was no one ever paying money who went around. I mean, those were the managers, yes, of course. But the managers or all my employees never had to pay in the first place. So that's where we also get the first learning, that just through our intuition, because we saw the process didn't went the way it was supposed to went, and that was already lucky, because most of the time we don't even see that, right? But most of the time, when people go around, or all the time, it's not because of money. So there was not any kind of monetary incentive to skip the process. There must be a different reason, and putting around a fence might solve that reason, but only on a symptom base, because the people are just physically not able to go around. Maybe if they have a huge truck and they go over the fence, yeah, sure. But in any other case, nothing is solved here. The symptoms are shifted, and maybe we see some different externalities which would then happen if we were not to solve the process. But fear not, because we have another page in store to solve that problem, or to let these get a bit more, a deeper insight on how to do it. Maybe first, but finish this page. We have call reception. Okay, so the people that were able to call the reception were the post guys, sure. Driver type unknown. Some people maybe that just didn't know what to do. And driver type visitor. Sure, okay. So I think this page is done with our analysis, and we now go to our lead times page, because now it really gets interesting, because we have some first hints on what could have actually happened, but we don't know really why the symptom occurred. Why did people bypass our process, which was so magnificently thought out, right? And on this page, maybe first as a small explanation, we have our process explorer again. We know that from the setup. It looks a bit different than the other one because we introduced the new additional information in it, right? For example, the lead time. Now, if you hover over it, you see also the average duration, the min duration, and the max duration. You see some kind of color coding, and if you see it here, it's based on basically the difference between the longest and short, or the average and the longest, and the longest ones are in the most red, right? On the top, we see the lead time, nothing new there. We could have a time filter. Yeah, sure, maybe we need it later. Here we have another tree map, so to say, so we could put some attributes in it, and we will see the amount of cases selected on the bottom. Two things which we will focus on also the most is this thing I prepared here. This is basically variants, so the 9 variants we had, sorted by lead time. And then we go down, and they're color coded in close gate. So that basically means someone went through the process successfully. It means leave gate, someone didn't go through the process at all, and pass gate, someone cheated. And we have the root cause analyzer, and we put in some explain bys, we put in car maker, direction, and driver type. And now I would suggest to drink and then go through all the variants. So let's maybe go through the longest one first, because let's imagine you want to go to a parking lot and it takes you 340 seconds, or the process takes 340 seconds. Maybe a bit long. So let's see what happened there. Okay, first of all, we want to know, okay, who was that actually who went through it? Okay, it was driver type visitor. So there was a lot of visitors, and we had the maintenance guys. Yeah, okay, that's already not so good, right? Because if we imagine I have a visitor, there's an argument to be made, it's only a visitor, why should I care? But maybe if it's not a parking lot where I want to make money, but rather basically a means to an end, and the end is a visitor, maybe a business partner going onto my premises and want to do big deals. And if that person has to go through such a long time through the process, that's already not good, right? So, okay, maybe we can find out a bit more, and then we can actually solve that problem. So let's see, what do we see on the left? Okay, we see 461 cases, right? 461 cases, and we see how they go through all the different stages. So they go through the nodes and what happens in between. So first we see someone approaches the gate, and it takes them 1 minute and 18 seconds to call the reception. Maybe a bit long, but since they're visitors, there could be an argument to be made that they just don't know how to operate, right? So maybe we have to make that a bit more clear, but nothing to be worried about yet. They call a reception and then they talk. That only takes 2 seconds on average. That's okay, right? Also, max duration is 6 seconds. So apparently there's always someone on the phone which is really eager to talk to you. And that person is so eager to talk to you that he talks really long. The average time till the gate opens is actually 3 minutes. So that's already a bit too long, right? I don't really want to talk 3 minutes to a person and have to maybe, I don't know, prove that I'm eligible for going on the premises. Okay, what else do we see? 10 seconds to pass the gate and 35 seconds to close the gate. Okay, 35 seconds, maybe not the fastest, but yeah. Our first learning is our visitors take way too long time to go on the premises, right? But other than that, we have some small ideas in the back of our head, but nothing really game-changing yet. The second variant, the second longest one, is someone who left the gate. That means that is a person who didn't went through the process, but also didn't cheat. They just approached, called the reception, talked to the reception, and then just left. And we see here, it's the post guys, so that makes sense, right? They just say, hey, I got a package, okay, leave it there. Okay, then the question is, why does it take, 4 minutes, 29 seconds? That's also way too long. And also maybe then we can already make an assumption, if for the post guys, it takes 1 minute 20, that doesn't really make sense that you can argue that it's based on lack of experience, right? Because the post guys, unless they change every day, they should know how to operate. So apparently maybe the automate on the reception is really slow, Maybe you have to rearrange your car 20 times to be able to press the button. Could be, there could be a way to contextualize already the knowledge. If you already see that everyone takes a gazillion years to operate their cars in order to press the button, okay, that could be a reason. So they talk to the reception and leave the gate. Again, the reception quite talkative, quite eager to find out what you're doing. And also for the driver type unknown, I guess those are the people who maybe drove in with their cars, didn't know that they didn't want to go here, talked to the friendly guys from the reception and then left again. Interesting, I guess, again, the problem with the 1 minute 20 till we call the reception appeared. The reception time was really a long time again, but nothing else new there. Now we go in the times that are a bit shorter, and here we have the driver type event. Driver type event, let's imagine an event. There are a lot of cases going through, right? There are a lot of people in an event case going through, because let's imagine it's a concert. Everyone goes in the beginning of the concert on the premises and then leaves on the premises. And what do we see here? Okay, insert money, open the gate, takes a long time again. Could be, again, related to computer being really slow, but maybe we don't care because, right, the event driver type is not a purpose of our business of having a parking lot, but rather it's maybe some kind of way to increase the utilization rate. But the second thing is a bit interesting. You see the 34 seconds here, and it always happens. So what could be a reason here now is, okay, let's imagine someone approaches the gate and waits 34 seconds till he inserts the money. And again, 34 seconds it takes for past the gate to close the gate. So we now see a first hint of, okay, maybe the gate just doesn't close right? Maybe the gate is really not that fast. Could be, but maybe we'll see a common pattern in the next steps. So let's go to the next one, which is virtually the same time, right? And here we see, okay, it's basically the same thing as the third case. The driver type changed a bit. It's the employees and the managers who are actually able to follow our case. And those are the guys and girls who press the button multiple times. And maybe now, after analyzing the data set for roughly 20 minutes, we already get a faint idea why someone would press the button multiple times, because the goddamn process just takes so long that you're so fed up with it that you just mash the button in, I don't know, some divine kind of intervention that someone please opens the gate and not just makes you waste 2.5 minutes of your life again until you actually start your day. So, okay, what else do we see? It's again those concerning opening and closing times. So makes sense, right? In the morning, everyone lines up to going to work. If I approach the gate and the gate is not closed yet, I have to wait 40 seconds. And it's again the same, or virtually again the same time that the gate takes for you to close. So there seems to be a common pattern. The time between pressing the button and retrieving the card, I guess a bit too long, but not too concerning, right? 30 seconds could be faster, but I mean, that's life. Let's look at the most common variant. Remember, that was variant 1. It was the one with 2,449 cases, and it's the employees and the managers. It's our way of how we want to have our cases handled, right? It's the completely normal case. And here we also see exactly the same patterns we have seen in the last times. It's the really slow gate that opens and closes in roughly 40 seconds. We have the pressing button time. The computer is not the fastest, but we don't really care because that is really something concerning. And that could actually be a reason for the process to be basically circumvented, right? And what about the 1 minute 10 case? Maybe just for completion's sake, okay, it's the people that are leaving, right? It's the second most, it's just everyone who did the first case does the second. And since we only have one gate, it's exactly the same problem again. We have people going 40 seconds to this agonizing pain of having to see the gate slowly closing down and slowly opening. So the gate got broken in November. Yeah. I mean, we could actually find that out. We can do that in the Q&A session. I'm not sure if the gate broke in December, but we have ways of finding that out. Keep that question in mind. Let's go through the different variants again. Yeah, so the second variant is the one where someone leaves. Yeah, sure. Agonizing pain in the existence of the gate, sure. Fifth process, yeah, those were the guys and girls who just approached the gate, called the reception said no. The post guys maybe just left their package, and the unknown guys went through their ways and trying to search a different parking lot where they can chill. The approach gate call reception time is again a bit concerning. There could be an argument to be made that there's a combination between the 40 seconds gate waiting time and the really slow gate computer, which we should really change and make it a bit faster, right? But other than that, the gate problem itself is only apparent in a quite of a derivative way, right? Through maybe guessing that that's the combination of this time. Now we come to the grand candidate for today. It's variant number 9. It's the variant where someone just didn't want to go through the process. And now we actually have a really good idea actually of why someone wouldn't want to do that. Because now we see, okay, it takes 29 seconds. We just approach the gate. We take the steering wheel to the left, we take it to the right, and we are done with it. And it's mostly the manager, and maybe it's the security guy because there was, I don't know, a break-in the night, who knows? But it's the managers that just maybe because of time pressure just don't want to endure the process. And I kind of feel with those guys because, yeah, it is apparent why that's a problem. And if you now imagine, it's not only the time where you go into the parking lot, it's actually also the time where you leave. So in combination, we could actually see how long the process takes. And we actually can do that right now. We have a lead time calculator where we can see how long the process takes. So let's see. We make approach gate and we say for the first variant, what is it? Close gate is not really, it's pass gate what we're interested in, right? Because close gate and pass gate is just the time where the gate went down, but you obviously already went through your way. So we see, okay, the process usually for someone who's going through the first variant on average takes you 1 minute, 32 seconds. And if we just say variant 9, I mean, that's basically the same. It's approach gate, approach gate and pass gate, that's 24 seconds. That's not right. Because I selected this. Yeah, so you see a difference there. So you can actually already guess why that is, why people would go around our process and would cheat basically their way through it. And this basically does the full circle of why process mining is quite important when we analyze processes, because even if we are in the lucky situation of basically knowing what the problem in our process was, that we are basically, that we are basically now enabled through process mining to actually know why it is and what kind of symptom it was that someone bypassed and how we can solve it. So that was our little presentation of the conscious parking lot and process mining. And if any one of you wants to try it out, we have actually a free visual available. You can either get it through the Microsoft Power BI store if you search for PAFNow, but you can also use the bit.ly here, however you like. It's up to you. So that's from me so far. I would say we will now start in the Q&A session, and we will have some questions and answers where also Philip will join me. And I thank you for your time.
Thanks very much, Mark. It was really impressive. First question from my side. So if you go back to Power BI, could you shortly, maybe in a couple of words, say something about the custom visuals? So you have like 2 lines of custom visuals. Usually I seen only 1 or 2 of them. So
yeah,
shortly go through.
Yeah, sure. So we have here basically 12 visuals and 9 are, 10 are from us and 2 we always like to use. So we have the duration card. It's basically this, where you can go through all different levels of durations. You could have it displayed on different units, however you like. I mean, we have, I guess we only have one level because it's minutes. We have minutes and seconds, I guess. So we have the duration card. We have the Pareto efficiency visual, which basically I haven't used it here because of the sake of time, but how we use it is we basically say if 80% of your cases are explained by 20% of your variance, you're already on a really good way. So that's how we use it. And based on the selection, obviously it changes. We have our Lord and Savior, the Process Explorer. This where you will find on virtually all of our pages when you would get the premium version, the full version. It basically would look like this, where you can basically pull in and out everything you want to do. Here we have the edge labels and whatever you want to do. We have the root cause analyzer. We already know about that, right? We use that extensively. We have the lead time calculator, the PAFNow event filter. I think that's really interesting. What you can do with process mining, maybe I will go to the questions in a second. What you can do with process mining is, for example, if you are interested in compliance, we made some custom visuals where you can actually see if, for example, certain resources violated a segregation of duties. So, for example, if people approve themselves in ways they shouldn't, then you can basically filter for those cases on a case level, and then maybe through Power Automate give it to your compliance officer, who maybe has the connecting tables between the pseudonymization and the clear names, and then he knows who did it and then follows up on this. So I really like to have the compliance with the case filter together. We have the document flow. I think I've never really worked with it, but I think we use it if you want to see where your documents are going through in your organization or in the process. I think Philip can maybe talk shortly about it. Philip, have you ever used the document flow filter?
Yes, so the idea is or comes from document-based enterprise resource planning systems. So this is a bit of a mouthful. And document-based ERP is something like SAP, for example, and the idea how they work is that they have objects which travel through their system. So you have, for example, a sales document, an invoice, etc. And this may be slightly different than what you actually see in the events. So you actually have events like approve this invoice. Exactly, you can see a screenshot now on your screen. And this may be slightly different than how your objects travel through the system. So for example, we have a couple of cases which may have numerous events within them, but you cannot see how the actual objects are related to each other. So for example, we have 7 cases here, and they are connected by a purchase order. So one order was filled out. However, there were a couple of invoices which relate to that order. So you can use that document flow to trace back maybe patterns that are caused by this scenario. So for example, you are seeing your gate is, I don't know, stuck or something, and then you can see, it's stuck only in cases where you have a specific purchase order in there. That would be a scenario that you could uncover with the document flow, for example.
Maybe that for context reasons, that is our documentation page. That's because I haven't put it up in our demo slide, and I also removed some slides. So maybe you can also see the Pareto visuals. That's what it would look like. I think what I really like is the case viewer, right? There's basically on a case level where you can see it, and you can also put in resources. That makes analysis really interesting because you can go into swim lanes. I think we have an example here. Yeah, right. When you go into swim lanes, you can see different resources interacting. If that's interesting to you, that's something I really like, and also our customers really like. I think that's virtually all of them. We have the KPI indicator. So how we use that is on the monitoring page, right? On the monitoring page, we use it. Let me just go to, I think, yeah. On the monitoring page, I just don't find it there. On the monitoring page, that's usually when we use it, for example, for management or like upper people who are not really connected to data analytics. Then you can specifically send that a monitoring page to them, and they can have basically based on thresholds, Power Automate and notifications. You can set them up virtually however you like. Those are just KPIs we always like to use, but you can use any other KPI you want. Yeah, I could technically.
I think it's okay.
Yeah.
There were also a couple of questions. Can you reshare? Sorry, Mark.
Yeah, of course. I can read them out.
Yeah, I can read them to you if you're.
Yeah, and please prepare your questions, so be ready to ask.
But we have some questions we can. So the gate broke on December. We not really solved that question, but maybe we could. But maybe that's I can do that in the background if I can find it out. I'm not sure if the demo data set gives that away, to be honest. But that was impressive. Is this fully built with Power BI? So it is completely integrated in Power BI. We basically put in our custom visuals, and the other thing that is basically what we call the Coca-Cola formula. So how we build our data model in order to have it displayed in Power BI. Because Power BI usually has a restriction on the amount of rows, I think it is, that you can display in each visual. I think it's 30,000. And with our data model through which you transform it, if you have really big data sets, you have to do the pre-processing, and then you can fully display them in Power BI. You can use everything you want, Power Automate, all the data connectors you want. We usually use SQL servers, but yeah, that's not a problem. Philip, you want to take the next question?
Sure. I was just adjusting, and I'm now sharing my screen. I think you are able to see it. I think the next one was about the root cause analyzer, wasn't it? Because I'm now.
Yeah. What's the root cause analysis? The top button. It tries to find common attributes values for filtered cases. Does those have different thresholds or something? So I think it maybe goes towards coverage and precision, right?
Exactly. So the idea is that the root cause analyzer tries to find a combination of the attributes you gave it. So let me find a good scenario.
I'm here. I did the question. So I understand that this is essentially trying to find the common attributes in the selected set versus the whole set, right? But what are the top buttons? What do they change?
So basically, if the root cause analyzer finds multiple versions which would explain the selection, it orders them based on the highest score it can find. And the not highest ones are getting sorted up here. So if you are, for some reason, this does not make sense, so or you're interested in alternative combinations that would explain your selection, you can filter through them and see if there is one that makes more sense. But usually, at least in my experience, it makes more sense in the first or maybe the second one to take a look.
Maybe you can show the grid.
Come again?
Can you show the grid, Philip?
The grid. Oh yeah, you're right.
I forgot it as well.
We also have a more scientific version to display how the visual actually works. Internally, we have two metrics, which is precision and coverage. And along those two axes, each of these combinations get ranked. And therefore, you can have a bit more of a scientific way to look at it, or with the boards and the coloring, a more like intuitive way to get the strength of the combinations.
So now we have did that answer your questions, MIU?
Yeah, I think so. So it's pretty close to the LDA model, right? The latent direct allocation to try to find attributes within the whole set, like the unique sets.
I would say so, yeah, somewhat.
Yeah, thank you.
And now we have a spicy one. Can you please compare your product with Celonis?
Yeah, so basically the first biggest difference obviously is we are based completely in Power BI. So as long as you are already using Power BI and you have your data in Power BI and so on, there would be a huge advantage. The next one is we have a lot more like a focus on smaller scale operations. So if you're a single data analyst or something like that, or just a team, we are probably more suited to suit your needs. Other than that, we also are super individualistic. So if you want to add stuff to your data model, etc., you can do that in the same way you are used to, as I said, in Power BI. So basically, those are the most core, I would say, differences. Is the asking person interested in a bit more specific aspect?
It's Alex. Alex,
I think you answered my question. Yeah.
Okay.
All right.
I mean, I think also the big thing is that Celonis built something standalone, right? They did their analysis standalone, and then because they were not embedded into the Power BI from Microsoft, where we have all the action connectors and all the data connectors, they had to build everything themselves. And the other big thing, which I think is actually quite important for also a lot of customers, is that PAFNow never gets in touch with your data unless, I guess you give us a VPN and then we help you build your data model. But we basically have the data always at the customer. You can either have it in the premises or you can have it in your cloud. And then it could be, for example, an Azure tenant from Microsoft, but we never touch the data. And obviously Celonis, because they do a lot from what they're doing through raw strength, they need to have it all in their premises, on their servers. And yeah, that's also a big differentiating factor, which can also be interesting when it comes to data security. Yeah.
Thank you.
Yeah. And I think you asked, does this product cost something extra with a standard Power BI license? So when you use the product from the Power BI side, you just need a pro license, I think, when you are an editor. And obviously, then if you are becoming a customer or your company is becoming a customer of PAFNow, you're paying them for our license. So for the PAFNow companion, where we do your data model, or where you do your data model and we support you with it, and then also for the custom visuals. The one I said in the end, like the free visual, where you can also really start with a small version of the Process Explorer, but as we went through them, there are multiple more.
Exactly. So if you want to start right now with the free visual, there are no extra costs incurring. But obviously, as soon as you want to go bigger data or make use of more of our other visuals that Mark showed earlier, then obviously a PAFNow license would become necessary.
And maybe if I want to add one thing, Philip said that we are really good in small customers, which is really true, because I know that certain competitors charge a lot for one use case, but if you want to have a different use case, you have to get a lot more again. You have to pay for all the use cases. And we can go small scale, but we can also, as we're already doing, serving Fortune 500 companies, which some of them everyone knows, also big ones in Germany. So we can also go big. It's basically also how you could use Power BI. You can use it in a big company, you can use it in a small company. That's, since we are so integrated in Power BI, it goes for the same for PAFNow.
Yeah, and maybe one more question from my side. So you are working with, so you're getting feedback from your clients and from the visual users who are using your visuals. So what do you see overall? Do they get the promise of the process mining itself? Because as you start you think it is, or you designed it, and that is how it really works. So there's a like totally different information and approach. So do you see that overall that this promise is like the process mining actually delivering this promise, and they find a way how to become more efficient using process mining?
Yes, yes, definitely. So it's slightly hinted in a slide that, or in a dashboard that we put in the back here, the discovery, which is usually our first dashboard. And if a process mining project gets rolled out at a new customer, this is obviously the most interesting step. And it's quite similar to what Mark did in the first place. So at first you go in detail through what did you do, what actually happened, and in what way does it differ from what you would expect. And usually this is also there are a lot of surprises, especially for new customers. And if the process mining project is one of the first process mining projects, they get surprised. So there are usually a lot of validations, a lot of also sometimes a bit of hair ruffling. How can this be? And this shouldn't be possible, and so on. And there are a ton of compliance cases or efficiency cases. And one efficiency case is, for example, where we had a customer in production, and they started to deploy process mining, and they grew so fond of it that they wanted to improve their delivery accuracy. So when they get an order, they already set a time when it is supposed to head out of the factory, and they increased that by, I think, far over 20%. So it was something in the 70s, and it now is far over the 90% threshold. And they did that by essentially having a super streamlined data pipeline in the back, and having multiple meetings over the same day where the people who are in charge of the delivery pipeline and getting the packages out the factory meet together, talk about the most current data, what steps need to be done, what to prioritize based on our solution, and then go ahead and execute those steps, and thereby actually improve their reliability in their predictions. This is just one very good example, but there are a ton of other examples where just having a simplified look at what actually is happening, like you're seeing right now, in itself can already make it so much more efficient or so much easier to optimize. That there are countless ways well, actually the promise of process mining definitely was delivered.
Yeah, thank you. We have another question in chat about wondering if the customers using this to process IoT data in the cloud rather than on-premise.
So I didn't get the first part. What do you want to do with IoT data?
Wondering if their customers using this to pre-process IoT data in the cloud.
So basically, this is a nice question. I really like the mindset, because technically, as we already discussed over here, I think in the data raw, the requirements are pretty minimal. So basically, you just need a grouping ID that groups individual steps that belong together. You need a name or an ID for each individual step, and you need a timestamp when it happened. So this actually gets satisfied by a ton of data. For example, IoT data, or also tracking data for like website optimization, for example, stuff like that. And you can also use that obviously for process mining. So you could, what we have here already, and feed it with slightly different data, but also analyze it for that. And unfortunately for me, or for us at PAF in the consulting role, a lot of people who already are in that league or are thinking about those things are pretty savvy, and they don't really need us. So we do not get that much feedback or knowledge from those projects, because usually the customer is handling them themselves. And we know that a couple of people are doing very interesting specific steps that do not really have process data in its core and more IoT data or some other kinds of data. But they are really happy, and as far as we can see, they are really successful in doing so. So the short answer is yes, you can.
So some related question to previous one.
Philip, can you
Yeah.
read?
I don't see the chat, unfortunately.
Okay, if there's some specialized process mining oriented data export format, like technical notation for the aggregated process graph with all variants and something similar.
There are some, but technically for us, it's sufficient to have anything that is in that format. So if depends on what your data storage solution is. So for example, if you have an SQL server in your backend, as long as you have in your end some kind of table or something like that, that at least gives you these three informations or data fields, plus any kind of other attributes that you can or that you may need, that's completely sufficient, and you can plug your Power BI report to that. So it kind of depends. You can also use the CSV files. I mean, you know Power BI, right? It's got tons of connectors. So there.
I mean, maybe Emma, maybe you can unmute yourself. I think he followed up with a question: ability to export something like that from the flat data.
Yeah, so the question is, I understand what data goes in. The question is more about, so there's a technical kind of notation for the graph that you're creating with all of the variants, right? Is there ability to export that in some format that would be readable by some other systems? I think it's a follow-up essentially to the IoT question that sometimes you would want to use this as a way to pre-process the data and get the aggregated variant out, but that's aggregated version of data out that would still describe most of the unique cases or case types within the data, but to lose the kind of granularity or just to minimize the amount of data.
Okay. So basically you want to have some kind of post-processing. So you want to have process mining essentially, and then you want to process your data somewhere else where you can do some kind of later on analysis based on what you could have seen in the report. Is that right?
Yeah.
Okay, so technically, yeah, sure, it would be possible, although I would think that you probably wouldn't want to operate on the output data of the visuals themselves, but rather you would want to work on the output of our transformation. But that in itself relies on or stays in your data source. So you already have that in your, I don't know, SQL Server or other kind of database or wherever your original data was. So I think it's probably even easier than you anticipate. So yes, again, I would say yes, you can do what you would have in mind.
Okay, thanks.
I'm sure you are working on some new cool stuff. Maybe you could share some things that we could expect, and maybe some new visuals or some more business look and feel like with customer journey, linking with the customer journeys or something like that. So.
Yeah, there are tons of like building sites, so to say. We already have a couple of features within just say the PAFNow Process Explorer. So for example, we have in the top corner over here a possibility to do a conformance check. So for example, now we do not have any conformance model behind this visual, so everything is marked as not conforming, but I can immediately say, okay, let's take the most the variant with the most cases in it and say this is conform. And now it tells us which steps are conform, which are marked green, which ones are not conform, which are marked red, and the ones that it would have expected instead. And now we can go ahead and adapt that, for example. So call reception after approaching the gate now is also conforming. So you could mark that as also conforming, and now it is changing, and you can see it also is marked as green, for example. And yeah, we are also in the process now. I don't want to share too many specifics already, but we are looking into integrating that a bit more and adding slightly more features in that stuff, for example.
Yeah, thank you. Thank you. We have question about modeling capabilities that I could maybe give a perfect process and then give some probably my numbers enter into it. So probably it's also you are thinking about stuff like that.
Exactly. Yeah.
Yeah, super exciting. Really, really, really valuable, especially this way how you go through the analysis logic. That was superb. So I say thank you to you, Mark, Phil, that you came today, and thanks for all others. And if we don't have any questions, so we have thank you, say thank you again, and yeah, you could post some information in the meetup chat how to contact you or some links to documentation, so you could do it directly to this meetup. So feel free to do it. Yeah, and be in touch, and hope to see you again sometimes in future.
You're very welcome.
If there are any follow-up questions, you can obviously also contact us. I mean, I post our email addresses in the chat, so if there's anything interesting for you, yeah, contact us, get in touch, and we can have a talk about it.
Exactly. We'll also post that in the meetup as you suggested, and yeah, don't be shy. Contact us or any of our colleagues anytime. We also offer trials if you are interested in a business, how do you say, business scenario, and we also are very much looking into any kinds of projects, helping you guys out, and do process mining all together.
Yep. Thank you very much. Okay, thanks
Great.
everyone, and have a nice evening. Take care. Bye-bye.
Greetings. Ciao, ciao.
Bye.
Bye.